Hey guys, it's Mr. Zimmerman, and we're going to continue where we left off, exploring the difference between a growth exponential and a decay exponential. Let's dive in, shall we? All right, from last time, we learned that there was two kinds of exponential functions, growth and decay, and if you kind of look at them, they all have a asymptote where the y-axis is. None of them touch that part. So let's go ahead and put this in mathematical context. So let's go ahead. First thing I'm going to do, sketch my coordinate grid to give me a frame of reference. My perfect graph. Now I know none of them are going to be below the y-axis. So growth is going to be increasing while decaying is going to be decaying. Now the only thing I need to be sure is the y-intercept is going to be at 0, 1, no matter what. Because whenever I take any number, 3 to the 0 or 213 to the 0, both of them are going to be 1. Now, growth is going to be increasing while really getting closer and closer to 0, while the other way, decay, is going to be getting closer and closer to 0 as x increases. So voila, I got a quick sketch of my graph. Now let's talk about it. My domain, it is just going to be negative infinity to positive infinity. Now you might recall why. In the past, 1 over 0 caused math to break the same way as a negative root did when it was an even radical. Both of these affected our domain, but nothing fishy is going on over here. It's all about the range. The range, I call it as a bottom to top scan, and you can clearly see that nothing crosses the x-axis. So my range is going to be 0 to infinity. It does not include 0. For those of you who are thinking it might have been 0 to infinity, it is not. It does not touch 0. It gets really, really, really close, but close isn't good enough. As we discussed, the x-axis is an asymptote, which is when y equals 0. Now, since it does not touch the x-axis, there's no way there's going to be an x-intercept. The final piece is to write the intervals of increasing and decreasing, and since growth, it is increasing. How long is it increasing? Well, if I look at my graph, it is increasing the whole time, from negatives all the way to positives. It's increasing. And likewise for decaying, it is decreasing as it goes from negative infinity to positive infinity. The last step is the most important because we're going to talk about the end behavior. As we go really far to the right and as we go really far to the left. And we're going to check this for both of them. Now, this is kind of like the domain, but this time we're going to get an exact value for each of these. So f of x is essentially a fancy way of saying the output, or a y, however you like to digest your math. And we're going to go ahead and look at this. As x approaches to the right, so I'm looking at my sketch right now. As x goes to the right, it is getting bigger and bigger and bigger, meaning infinity. As x is going to the left, what is happening? It's getting really, really, really close to 0. Same thing. As x is going to the right towards positive infinity, it's getting really, really, really close to 0. And as I go to the left, it's getting much and much bigger. So a good exercise to do this is to recreate this table not once, twice so, and make sure that you're able to generate this information yourself. Check with the key on Canvas and continue to explore mathematics. I hope you guys all enjoyed this. It's been a wild ride. Happy learning. Peace. Or ciao.